สวัสดีค่ะท่านแขกผู้มีเกียรติทุกท่านค่ะยินดีต้อนรับทุกท่านค่ะเข้าสู่งาน Thailand Lab International 2022 ซึ่งในครั้งนี้ค่ะจัดร่วมกันกับงาน Bio Asia Pacific 2022 และงาน Future Camp International 2022 ค่ะกับงานนิทรรศการและการประชุมด้านวิทยาศาสตร์ชีววิทยาศาสตร์และงานนวัตกรรมด้านเคมี ซึ่งถือว่าเป็นงานที่ยิ่งใหญ่ที่สุดในระดับภูมิภาคเอเชียแปซิฟิกค่ะโดยทั้ง3งานในครั้งนี้เกิดขึ้นจากความร่วมมือระหว่างกระทรวงการอุดมศึกษาวิทยาศาสตร์วิจัยและนวัตกรรมโดยศูนย์ความเป็นเลิศด้านชีววิทยาศาสตร์องค์การมหาชนหรือ T-Cell Thailand Center of Excellence for Life Sciences และวินยูเอเชียแปซิฟิกร่วมกับภาคีเครือข่ายทั้งภาครัฐและเอกชนค่ะโดยงานในวันนี้จัดขึ้นเป็นวันที่3แล้วนะคะเพื่อนำเสนอนวัตกรรมตลอดจนเทคโนโลยีทางด้านการค้นคว้าวิจัยและความร่วมมือทางด้านชีววิทยาศาสตร์โดยผู้เชี่ยวชาญทั้งจากในไทยและจากนานาชาติค่ะโดยงานในครั้งนี้นั้นนะคะเราได้จัดขึ้นในรูปแบบ Hybrid Exhibition ซึ่งเป็นการผสมผสานกันกับการจัดงานแบบ On Ground Exhibition and Conference และการจัดงานในรูปแบบ Virtual Conference ด้วยกันค่ะดิฉันจูนจุติมารับหน้าที่ผู้ดำเนินรายการในครั้งนี้นะคะ Good morning A very warm welcome to all of you to Thailand Lab International 2022 co-location together with Bio Asia Pacific 2022 and Future Camp International 2022 This conference is the collaboration of Ministry of Higher Education, Science, Research and Innovation by Thailand Center of Excellence for Life Sciences or T-Cell together with VNU Asia Pacific and Public and Private Partnership. And today is the third day of this conference. This conference is a joint seminar of Thailand Lab International 2022.And there will be a presentation about innovation, research technologies, and collaborate with the field of life sciences by the experts from Thai and international. Where you can define these events at Hybrid Exhibition and Conference, which is a combination of both on-ground exhibition and conference together with virtual conference. I'm June Jutimar, your MC for this event.ซึ่งทุกท่านนะคะสามารถเลือกรับชมได้กับทั้ง2ห้องด้วยกันนะคะทั้งห้อง Conference Room ค่ะและห้อง Lab and Bio Square Room นะคะโดยขณะนี้ทุกท่านกำลังติดตามรับชมกันอยู่ณห้อง Lab and Bio Square ค่ะ We have seminar which is running separately into room where you can shoot either from conference room or here at Lab and Bio Square Room and you are now with us watching from Lab and Bio Square Room สำหรับในช่วงแรกในวันนี้ค่ะเราขอนำทุกท่านติดตามรับฟังหัวข้อที่น่าสนใจนะคะซึ่งจัดโดย Bara Scientific Company Limited ค่ะเริ่มต้นกันด้วยหัวข้อแรกในวันนี้กับหัวข้อ Compact with Countless Benefits โดย Shimatsu Latest MS Invention ค่ะซึ่งเราได้รับเกียรติจากคุณนิโคลจางจาก Shimatsu Asia Pacific นะคะซึ่งให้เกียรติเป็นผู้บรรยายในหัวข้อนี้ค่ะ Start the day with the first topics co-organized by Bara Scientific Company Limited with a compact with countless benefits, Shimatsu latest MS invention. So, ladies and gentlemen, please join me in welcoming our speaker on the stage, Ms. Nicole Zhang, LCMS Product Manager, Shimatsu Asia Pacific, Singapore. Welcome.
Thank you, June. Thank you for the introduction. Sawadika.So I wish I could continue my presentation in Thai, but unfortunately, I'll make it possible next year, okay? All right, so thank you for spending time with Shimatsu. I'm sure some of you already know Shimatsu, but let me just spend the 2 minutes, have a very brief introduction about the company. So Shimatsu, we have already in the market for close to 150 years. Back to 1875, we established in Japan, Kyoto.So we are the longest analytical instrument company in the world. But we are not only dealing with analytical solutions, technologies. We are also having medical devices. We are also working very closely with the different industries as well. So let me give you one example. So any of you started traveling, right? So you know that whenever you take the aeroplane, no matter it's Boeing or the Airbus, the landing gear,So part of the landing gear is also coming from Shimatsu. So Shimatsu is really a true innovative company which is not only focusing on one area, one scientific, one technology aspect, we actually having a multiple technology, multiple divisions as well. Okay, so back to our topic for today, the most related to the analytical solutions, analytical industries. So if you can see here, we have a very rich of the histories about Shimadzu, of course, close to 150 years. But the most closest to analytical solutions is actually back to 2002. Our engineer Tanaka-san was awarded as a Nobel Prize in chemistry. So this is actually with our multi-top technology. And also back to 2009, that is the first time Shimadzu launched the first ultra-fast mass spectrometer. So we also call it UFMS. So whenever you hear about the UFMS, that is the branding from Shimadzu only. Okay? So this is all about a brief introduction of the Shimadzu technology, Shimadzu corporate. UFMS, as we mentioned, that is our trademark, right? So, but this is not just limited to the LCMS or the GCMS. It is actually across the whole mass spec products from Shimadzu, from GC single quadruple to LC triple quadruple, even the SAP-MS as well. And don't forget, earlier I just mentioned we have the multi-TOF technology. We have the TOF, Q-TOF technology as well. So all this actually provides a platform of the MS solutions from Shimadzu. And we have been continuously awarded as the Mass Spec Company of the Year for Asia Pacific since 2015 to 2018. So if you can see here, we are not just a company providing one unit of the technology or one model of the instruments. We are providing a complete solutions for all of our customers. 50 years in the mass spec. So the first mass spec, not only the UFMS, but really the first mass spectrometry instruments from Shimadzu was actually from 1970. I think I'm a bit too ambitious. So we have already had 50 years in terms of the MS experience. 2 years ago, that was still under the COVID time. So we celebrated our 50 years of the MS technology. So if you can see here, we have done so many different innovations, interventions of our MS technology. And currently, at the moment, which is the most right side, so what you can see right here is all the current models or current flagship models we have from Shimadzu, okay? From GCMS triple quadruple system, LCMS triple core system, Q-TOF, as well as the advanced multi-TOF IM scope or different technologies. MS has been widely used in almost all the industries. So whether you are working with cannabis now requires the MS to do the safety test, pesticide residue, mycotoxin residues, right? But of course, that is just one application. All the food safety customers require the MS to achieve the more sensitive results in order to comply to the regulatory requirements. Pharma industries, no matter you are doing the research and development or you are doing the API quality control, different type of the MS technologies are required. So from the more sensitivity required impurity test to a general API test, a different mass spec will be applied in the application. And of course, forensic clinical are the huge market, not only in Thailand, globally. Because of MS can provide you the sensitivity, the selectivity. So when you are dealing with such samples, it can help you to reduce the matrix effect. It can help you to achieve the sensitivity of the required. Okay? And of course, all the life sciences, the BABE customers, all these are required the MS technology. So MS is really a true routine analysis tool for most of the laboratories. So in terms of how we choose which technology, which particular instruments we are going to use in the routine, in your laboratory, back to your application. So when we are looking at the analytical analysis or the whole complete workflow, regardless which laboratory, which application you are working on, but there are always of the two separate application or two separate workflows which will serve your purpose of your application, your research. So if you can see right here, we have non-targeted analysis and also a targeted analysis. So targeted analysis is relatively easy. Basically, we need to confirm whether the certain analytes, certain compounds are in your sample or not. And then if they are, you will do a further quantitative analysis. This is a pretty straightforward of the routine triple quadruple workflow. So you'll know triple quadruple is the most classic quantitative tool. And on top of that, there is another unknown analysis workflow, or we also call it non-targeted. But in non-targeted, it's slightly more complicated. One is what I have circled here, is the targeted screening. That means we have the library, and then you just need to test out whether in your sample, those in the compounds in the library appear in your sample or not. Those also can be applied by the triple quadruple technology. But then there is another very complicated, the most complicated workflow, which is so-called discovery workflow, which is working on non-targeted, unknown kind of application. So that requires another technology, which is the high-resolution accurate mass instruments. So from Shimazu, it will be the Q-TOF technology. So let me just quickly introduce both of the technology from Shimazu to see how it can help you in your applications. As we mentioned earlier, 50 years in mass spec is a long time. Although our triple quadruple system, the first model, it came at 2009, but if you can see the roadmaps, we have been continuously improve our technology, improve our hardware, improve our solutions to meet customers' requirements, to help customers to solve your problems, from sensitivity improvement to robustness improvement, as well as to make customers, especially the scientists' work life much easier. So currently, we have different models of the LC-MS triple quadruple system. The most high-end, the flagship model, is where you can see here, 8060NX. Okay? So along so many years of the MS history or MS development, we are continuously to improve the sensitivity, the speed, and to improve your productivity in your laboratory as well. What's the difference? Why we made this flagship model of the LC-MS 8060NX model? So if you can see, this is actually the core of the instruments. Okay, so you can see a different part of the instruments. It looks pretty much similar to most of the instruments, or most of the triple quadruple instruments. You always have an ion source, which is the interface to connect your LC samples, or your LC instruments, or even your LC column, particularly, and then connect them to the mass spec. And the ion source will ionize your sample from the liquid form to individual ion droplets, and then transfer them into the mass spec. And through the ion transmission pathways, there are different lenses to help you to focusing on different ions as well. And eventually, the more ions reaches the mass spec, reaches the detector, the better sensitivity it will be achieved. Okay? So what we do is, we have improved from the ion source itself to the ion optics, the focusing units, and of course to the mass spec, to the detectors as well. So what are the details, things we have been working on? So for ion source, this is the latest model, or latest design. We also call it ion focusing unit. Okay? So this ion focusing unit has additional benefits to the customers. We apply additional voltage, which to create an electrostatic field force. Okay? And on top of that, we have additional gas dynamic, the heating gas dynamic, to helping the ions to improve the ions transfer into the ion transfer tube, or we call it desolvation line, into the mass spec. Okay? So as a result, what you can see here, the sensitivity improvement are significant. So if you just look at the pesticide right here, of course, individual compounds will have a slightly different in terms of the sensitivity improvement, but overall, we actually see across the board, that means to apply for different applications, we do observe a sensitivity improvement minimum about 2 times, even for the pesticide analysis, okay? Because pesticide analysis generally requires much higher sensitivity, and this is always driven by the regulations. And the regulation never stops at one point. It's keep updating every year or every 2 years. So all this, we are trying to design the software, design the hardware, a technology, is to helping our customers to address your concerns. Okay? But of course, sensitivity improvement is not just only for pesticide. It's not just only for what I list down here. Those are just few samples. Okay? So if you do have a chance to take a look at the instruments at our booth at the Bara Scientific together with Shimazu Scientific, so you can take a look at the instruments as well. Okay? But again, iron source is the first step to improve the sensitivity of your targeted analytes. Okay? But we never stop here. Okay? So if you can see here, we always improve our sensitivity throughout the whole technology refreshment, whole technology upgrade. The second upgrade is iron focusing units, the iron lenses. So what we do is we change a different, or we apply a different RF voltage. So you can see the two samples here. So let's say the MCAA. So those samples, those nanolites are relatively small in terms of the molecular weight. So whenever we see it small, we are looking at M/Z value less than 150. Because you're as experienced MS user, smaller M/Z value usually give us some headache in terms of the sensitivity. It's not easy to achieve higher sensitivity, okay? Because during the ionization, there are always some reactions between your ions as well as your gas. So what we do is we apply a higher RF voltage, which you can see right here, when you apply 30 versus when you apply 60. This is actually under the iron focusing units. And what we see is the sensitivity improvement of the close to two times. Okay, so this is what we do. So this part of the design is specifically focusing on the smaller molecule analytes, which we are specifically referring to M/Z value less than 150. Okay, usually the mid to high molecular weight or molecular M/Z range compounds, you shouldn't experience much problems. The smaller ones are giving us most of the headache. Again, speed. As I mentioned earlier, 2009, that's the year Shimazu launched the first ultra-fast mass spectrometry, UFMS technology. So ever since then, this UFMS core technology, it is in our mass spec, in every single model of the mass spec. Because we believe customer samples are not just analyzing a few compounds for one analysis, because this is not very productive, right? And also our customers is always looking at multiple or hundreds or even few hundreds of analytes within one single analysis. And on top of that, if it's just for screening, maybe not so high scan speed required. But when you are doing the quantitative analysis, that means you need to have a minimum 7 points across the peak. That the speed plays a very, very important role. So this is how we are achieving it. By using the UFMS technology, if you can see the sample right here, this is about 30 minutes run time, analysis time. But we were able to analyze about 647 compounds. And this is for food customers, pesticides. Okay? So if I just zoom into this window right here, this is about 9-second window. It's just 9 seconds, okay? Actually, under this or within this 9-second window, we have 25 positive and negative compounds. What does that mean? That means we are doing positive-negative switching, all right? And for each pesticide, because we have 25 here, each pesticide, we have 3 MRM transitions. That means 9-second window, we have positive-negative switching, and total we have 75, is that 75? Yeah, 75 transitions, and with optimized collision energy. All right, so now you can understand how fast, how UFMS technology can help you to achieve. This is just not just for screening. This is for quantitative analysis as well. So if you are interested, you can always go to Shimazu website or just Google it. We have this application notes for 647 pesticide analysis. You can see all the calibration curves there as well. Okay? So this is how we are helping our customer. It's not just to develop some instruments which is okay for the customer, but we are helping customers to achieve your analysis efficiency as well. Speed made it possible. So the UFMS technology is the core of any Shimazu mass spec. Okay, after we discuss about sensitivity, after we discuss about the speed, so wonderful results. So the next is always the robustness. Okay, customers don't want to have a downtime. We want the instrument to maintain its best performance forever. But this is a kind of unrealistic unless we maintain our instrument properly as well. But our instruments, because of the different design from the ion source to the ion optics to the triple quadruple systems, okay, a series of the development of the hardware, we at least can make sure the robustness is maintained at certain conditions. Okay, so we have a sample here. This is actually, you can find the data. This is published during the ASMS. We have about 1,000 injections. Yeah, 1,000 injections. This sample is human urine sample, so it's biological samples. We just do a simple dilution in water, 1-to-1 dilution. And then that means biological sample usually having a lot of matrix effect, very complicated, okay? And it's make your ion source getting dirty very fast as well. So what we do is we do a quick injection, 1,000 injections continuously at flow rate of 400 microliter per minute. What we achieved, if you look at the RSD percentage, less than 8.4%. Because based on the analytical chemistry, anything for the mass spec, RSD, any RSD within 15% is acceptable. But again, for our real data, real results, it shows less than half. It's about less than 8.4%. And this is just with external standard. Okay? So this is how robust the instrument itself. And this is not going to be achieved if you just design or improve a little bit on the ion source. This is really the achievement of the complete system technology upgrades. So this is how the LCMS 8060NX we are helping our customers. Okay, so after all the hardware improvement, after all this performance of the best instruments, the customer is always complaining about the data analysis. Because I was a chemist before, I worked with a food safety lab, so I understand how painful the chemist job was, okay? So I remember when I was a chemist working with this regulatory agency back to other countries. So they have to morning do the sample preparation, okay? And then afternoon, put all the samples, pre-treated samples in the instruments. And then second day morning, again, data analysis, followed by sample analysis, followed by sample preparation. Daily routine is nothing really new. But the thing is, every day we are preparing more than 100 different types of sample. And we were testing more than 300 at that time, pesticides. Okay? How can I review my every single sample and each sample 300 pesticides? Second sample, 300 pesticides. I cannot just every single day repeat the same thing because my laptop is small, screen was small, and my time is limited. So because of this pain, we develop a software. It's very easy function. We just call it color coding function. If you can see a different color here. So what we like customer to do is that you just need to set up a criteria. You tell the system, what is your outlier range, right? And then you tell the system what is the acceptable range. And then the system will automatically, based on your criteria, label as different color. And the label is just not on the sample table itself, okay? Top is the sample table. If you see the chromatogram, calibration curve, all these are labeled with respective colors. You don't have to go through every sample and each sample 300 compounds, no. You just look for those colors. So this makes our chemist life a much easier life, okay? A very simple development, but what we are trying to achieve here is really helping our customers to improve their productivities as well. So yeah, that's about the triple quadruple system. So what about the most difficult high-resolution accurate mass instruments, which is for totally unknown discovery workflows? That is something not very easy, okay? Anything to do with discovery workflows, it will be a complicated application. This is regardless of which instruments. Even you have the best instruments, best softwares, any discovery workflow still require a lot of human data interpretation as well, okay? So we have LCMS 9030, which you can see a little bit big right here. We are a little bit slow in terms of developing of the QTOF technology, but we are always using the latest technology, all right? So we have the higher resolutions, which are actually ensured by a different ion UF greeting system, by the eye reflectron technology. But because everybody having high resolution instruments, every suppliers will share with you the importance of the high resolution. No doubt, high resolution provides a better separation, which helping you in terms of the discovery workflow. But it is another very important aspect of the high resolution instruments is the mass accuracy and stability. We can have the best resolutions in the world, but your mass accuracy is fluctuate very often, very fast. And then what's the purpose of having a high resolution instruments? So in Shimazu, we did a test, okay? This was conducted in Japan. We have a special dedicated room for a new instrument test, okay? So in this room, we managed to make the temperature change 6 degrees variation, okay? And if you can see here, in the positive ion mode and also the negative ion mode, even with a temperature fluctuate of 6 degrees, but for both positive and negative, the mass is stable for 24 hours because we monitor for 24 hours. And also is within the ppm level, 1 ppm level. So this is how stable it is, because usually the QTOF technology or any of the high resolution technologies are very sensitive to the temperature. Okay, 6 degrees for any of the laboratories seems a bit unacceptable. Okay, but we make the conditions at extreme, so we want to really test out the mass stability. So of course, on top of that, we also test out for mass accuracy through a mass range. So if you see the previous slides, we're focusing one compound for the positive, one for negative. Now we are actually checking the accuracy across the board from 100 to 1,700. For most of the small molecule customer, this is a sufficient mass range. Okay, so if you're looking at the mass range, the ppm column, the red color, hardly anything is over 1 ppm. You have a few over 1 ppm, okay? But majority are still within 1 ppm. So the mass accuracy is important in terms of giving you a confidence in terms of discovery workflow, okay? So for any of the high resolution instruments, you need to combine both high resolution as well as a mass accuracy and stability. And combining both, you have a better confidence in your data, in your results. So who are the applications, who are the customers using high-resolution instruments? I think you all know. Discovery workflow is one of them. Identification, confirmations, non-targeted applications, and of course, in a lot of research, customers also doing this advanced, high confidence level of the research as well. And of course, even you just want to analyze your compounds in a highly complex sample matrix, that is also possible. So for your information, we are also coming out our new LC QTOF. Okay, stay tuned with us. I'm sure our partner in Thailand, Bara, will be informing you shortly on the latest QTOF instruments as well. Okay, work efficiency. Just now, we are always talking about the mass spec technology, right? MS is a core of any LCMS, GCMS technology, but we can never forget about the front end. What about the LC part, right? That is also play a very important role. Of course, we are using the analytical intelligence software, analytical intelligence algorithms, okay? Which allows our customers to monitoring a lot of different routine analysis aspects. For example, our AI software can help our customers to monitor the mobile phase level. What does that mean? So if you want to set up any of the overnight run, right? So if you only have maybe 200 mil of the mobile phase left, after you set up your sequence, the software will automatically calculate for you to see whether it's enough, sufficient amount of the mobile phase or not. If not, they will give you a message. They will pop it up by saying, not enough mobile phase to complete your sequence. Okay? And this can be set up not only on the acquisition PC, it can be set up on your mobile phone as well. Okay? So, and also, sometimes, right, after you run your analysis, you just put the instrument into the auto sleep. Then the second day morning, you want to come to the lab before you start your analysis. You can start condition your column maybe 30 minutes before you start your analysis. You have the options to set it up through your mobile phone. Okay? So this is the beauty of the AI algorithms in the LC part. So we believe that LCMS is a complete solution for the customers, and we should provide a complete algorithms, smart laboratory ideas to both of the instruments, not just LC, not just mass spec, but connecting everything together, which is improve your work efficiency as well. That's all about the hardware, okay? So what about the software? If your customer, you start a new laboratory, if you want to do something like food safety, if you want to do something PFAS analysis, which is another popular topic now, you do have the options. Well, this is only from Shimadzu. We have options called method package. Method package is not a simple MS database, okay? It is really the method package. That means when customer has this method package, which is already including the LC conditions, that means column, mobile phase, gradient, okay? All this information are included. You don't have to develop your method from scratch, from zero. And on top of that, it also includes the MS setup. That means MS, the hardware setup, the ion source setup, the voltage, the gas, and also the MRM transitions. So this is, we are not calling it a simple database. We call it a method package. So this is the concept of the method package. It really provides a complete method, which you can start applying these methods in your application, even you have no knowledge prior to your analysis. Okay? Well, we just list down here a few common popular method package, but we have much, much more than that. So currently, in total, we have more than 24 different method packages. Okay? All right, so that's about the triple quadruple system, about the QTOF, which is routinely applied in a lot of laboratories. Let me also introduce another new instrument. This is something really new. Last week, we just launched in other countries. So Thailand is the second country we launched it, okay? We call it Shimadzu LC-MS 2050. But before I go into the instruments, let me give you this idea. Living laboratory. What does a living laboratory mean? So living laboratory is really about we as a human, we teach the instruments, okay? That means we teach the instruments, the hardware, how it can automatically run the analysis for us. But this is not enough. We also have a living algorithms, living algos. We also tell the system, but this time we tell the software how it can automatically calculate using the machine learning algorithm to calculate, to interpret the results for you. And eventually, we want to achieve the living laboratory, which is also connecting with other lab management tools. For example, LIMS. For example, your Lab Solutions CS, Lab Solutions database, all different softwares. So LC-MS 2050 is the first mass spec in the living laboratory concept. Okay? LC-MS 2050 is a single quadruple system. I know some of you may ask me why you are introducing a single quadruple system. Because customers are working on the high resolution instrument for your targeted analysis. You are working with a triple quadruple system for your routine analysis. Because it has sensitivity, grid selectivity, right? So why we develop a single quadruple system? Because we do notice that a lot of customers, pharma customers, food customers, or even cannabis customers are still using the LC as a main solution. But then at the same time, yes, no doubt, LC is one of the most mature analytical technology. It provides you very robust, okay? Unlike mass spec, which requires a lot of maintenance. It's very robust, it's very affordable. It can do a quantitative redox analysis for you. But what are the limitations? Because not all the compounds are UV absorbing, right? A lot of compounds are UV transparent, let's say sugar, okay? And for LC method, you still need a good separation, chromatographic separation. So, but then what a customer wants, they always want to, firstly, they want to have more or better in terms of the sensitivity technology, okay? So they want to also to install a better MS technology on top of the LC, all right? And they don't want a complicated operation. They don't want complicated data interpretation. And they want to work from everywhere, work from anywhere. So that is where we want to develop the LC-MS 2050 instruments, okay? So if you can see currently for the LC, we have all different types of the detectors from UV, ELSD, fluorescence, all different types of detectors. However, mass spec MS is really a universal detector. It has a better selectivity, better sensitivity, okay? And it can really simply add on to any of the Shimadzu LC system, existing LC system, as an additional detector. Okay? This is the system of the LC-MS 2050. All right? And if you can take a look later in the booth, we have a display down there. Okay? The mass spec is really just this part. Okay? It's very small, very compact, right? It's one of the smallest compact LC-MS detector, but it never compromises in terms of the performance. Just now, I think we mentioned already that the PDA detectors, it is great in terms of the robustness, in terms of the quantitative readouts, affordable, but we also have a different limitations as well. So that is where we developed this mass spec, okay? Because of this compact in terms of the size, so now we're connecting the LC PDA together with mass spec has become surprisingly easy. And what mass spec can provide to you? Of course, it gives you additional dimension of separation based on the molecular weight information. It is more sensitive, it is better selectivity, but then at the same time, what happens is that you need a lot of time to interpret the data. And operation, I think a lot of customers was asking, mass spec is different from LC. I agree. Operation may be slightly more complicated, but I'll show you how the LC-MS 2050 will make the operation, data interpretation much easier for any of the LC users. So the operation is not complicated at all, okay? So even the customers without much of the MS background, you can also easily operate the LC-MS 2050 system. I think a lot of LC users look at this will be scolding me that what is this, right? This is unacceptable chromatogram for an LC user. But this is pretty much accepted for the mass spec, okay? Because for any of the MS, we are always looking at the extracted ion chromatogram rather than total ion chromatogram. If you're interested, can take a look of the application notes, okay? This is already available on Shimadzu website. Okay, so I will go through a few different points to explain a little bit more on the 2050 itself, performance itself. A lot of customers, right, especially when they are from the LC backgrounds, so they don't have much of the MS experience previously, okay? In terms of the ion source selection, some compounds, especially mid to high range of the polarities, are good with the ESI. Some low polarity compounds is good for APCI, or is more efficiently ionized through the APCI technique. But then, that means when you don't have much idea about your analysis, your compounds, you may need to have two separate analysis, one with APCI, one with ESI. Okay, that means you need to run twice. And on top of that, your mobile phase need double. So what we do is, specifically for LC-MS 2050, we develop one heated ion source. We call it Dewey's ion source. We're combining ESI and APCI together. and this is heated source. So why are we doing this? Because when you don't have, for R&D customers, when you don't have much ideas about the compounds you are working with, one ion source, one analysis, the instrument will automatically compete with each other and to choose the best ionization technique for your compounds. Okay? And of course, for routine customers, although you already have the information of your compounds, but by using the heated ion source or heated Dewey's ion source, you only need to analyze one time of your sample. So you save the time as well as you save your mobile phase. So this is what we are doing, that why we developed the heated Dewey's ion source. Okay? And this is how the source look like. It's right here. All right? So we have one application right here, vitamin analysis. Water soluble, which is ideally with the ESI ionization technique. Fat soluble, which is great on APCI ionization techniques, right? But I think they both are very important. For example, vitamin C, water soluble, which is very important in terms of helping us to build up the better immune system. But at the same time, the vitamin D, vitamin E, those are very important in terms of delay our aging. Okay? So if you Google any of the application notes now, okay, online, you can still see some are coming from water soluble analysis vitamins. Some applications focusing on the fat soluble. But then we have just developed this method 2 weeks ago back in Singapore. One analysis, one sample analysis runtime, within 8 minutes, we managed to combine both water soluble and fat soluble together in one sample. Okay, so this is how the result look like. So stay tuned with us for our application notes. It should be coming up in within next 2 weeks. Okay, so you can see a more detailed information how we conduct the analysis, how the result look like. Okay. So that is why we are applying this heated Dewey's ion source for our customers. Mass range, okay. Of course, a lot of customers are saying that mass range maybe not very critical, but when we are analyzing the mid to high molecular weight compounds, that is very helpful. For example, what I'm showing you here, oligosaccharide polymerization. So polymerization, basically your saccharides are connect to each other, okay? If you can see some data here, so this peak, or this chromatogram actually shows the peak from DP1 to DP20. So for example, if your mass spec, it can only go up to M over Z value of 1,500, for example. What you're missing is DP 18, 19, and 20. Basically, the 3 peaks are missing. Okay, it's probably just few peaks, but this is more than 10% of your data analysis results are gone. All right, so it's not just numbers of peaks, it's really how complete your data analysis is. Okay, whether your instrument is capable to detect different peaks, or it can give you the peaks information or not. All right, and then robustness. Just now to a triple quadruple system is such a routine analysis tools. We're talking about the robustness. But again, robustness is also very important for the single quadruple system as well. Eventually, it's still MS instruments. Okay? Again, our development is not just for one part to improve robustness. We have all different technologies combining all them together to improve the instrument robustness. So for example, the first thing we did is, after the ion source, we have a wider, slightly bigger in terms of the MS inlet, okay? And then that means it has a better tolerance to the clogging. And we have the heating gas technology, so prevents any of the uncharged ions going to the mass spec. And we also have the charge vapor technology, which is helping instruments, or improve the ion transmission efficiency. Okay, combining all this together, real data always speak the best. Okay, so if you can see that peak area RSD percentage is less than 4% after 1,000 injections. So all this, every single part plays a very important role in the whole robustness improvement. Okay, integration. Remember I was saying that LCMS 2050, it is a detector. It's a universal detector. It's more than a mass spec, right? So what does that mean? It is actually can seamlessly integrated into any Shimazu LC, okay? Whether you are working with our latest Nexera series, our I series, which is right here, or even the PrEP LC system, it can seamlessly integrate it. And even with the legacy model. It is not just about the hardware integration. Integration should be coming from both hardware as well as software, okay? We always believe software and hardware, it must be combined together. So if you can see the method set up, some LC users are very familiar with all the part, the LC setup. Only the last part is the MS add-on. And the add-on is very similar. So for example, for PDA detector, you are just giving a wavelength range for the particular wavelength. So for MS, it's relatively simple. Instead of the wavelength, you give a molecular weight information. Because remember, MS is always giving you the additional separation dimension based on the molecular weight. Okay? That is the only thing you need to put in. All right? So, okay, and what's the next? The ease of use. Ease of use is actually combining a lot of different things. For example, performance concierge. What is that? The customer is able to automatically let the system run the tuning and the calibration, to let the system judge themselves, and to check the mass accuracy, the resolutions, the different criteria. Okay? If it's passed, best condition, you can start your analysis. If it's failed, just do an auto-tuning calibration, that's all. Okay? So all this we are trying to do is trying to helping our customers to reduce their routinely maintenance of the instruments. Okay? And all this actually throughout the analytical intelligence algorithms. Okay? Eco-friendliness, sustainability is something important. And maintenance is relatively easy as well. This is tool-free. Okay? So, well, after we talk about all this, what about the algorithms? Remember, I always emphasize hardware, it must be great, but then data interpretation must be easy for our customers. Only combining both, we can provide the best solutions. Why customer wants to upgrade LC to a MS? There are three different benefits. Of course, what you see here is to labeling what the UV chromatogram with the MS information. That can be easily achieved. Then what about the rest of the part? What about the UV transparent peaks? What about the co-eluting peaks? All these are the challenging parts. So we have a sample here. We have a very unique, novel deconvolutional software or the algorithm, which is helping our customers to work on these two features, UV transparent peak, co-eluting peak. So if you see here, the top, the chromatography, we have 7 different compounds. But then, when we are using the massive function, okay, it actually shows 2 additional peaks right here. So this is the UV transparent compounds, which can't be detected by the UV detector. And then, there are also a co-eluting peaks, which is marked as yellow color. So if you are just using the LC, right, could be just 1 compound. But then, only with the MS information, with the massive function, it is actually the co-eluting of the 2 compounds. This is the beauty of the massive function. And this is actually how our customers are motivated to upgrade from the LC system itself to an additional universal detector. Another one is the peak intelligence. Okay? So peak intelligence is something for data integration. And then this is actually helping our customer to automatically integrate different peaks. So one is to save a lot of time of the chemist. And the secondly, so for the peaks right here, the integration can be a bit challenging, can be very different from different scientists. So the software is not only just to help you automatically integrate all the peaks, but it also helps you to integrate at the same algorithms, same standard, to avoid any of the scientists' variations. Okay? And all this just by one single click, which is right here. So the peak intelligence, which is on your left side. Okay? So all this is actually helping our customers from the data processing, data interpretation, perspective to make it much easier for all the MS users. Okay, so LC-MS 2050, as we introduced, it is really the first living instruments, but also together with the massive function, with the peak intelligence, we also have the living algorithms as well. But the Shimazu solutions of the living laboratories is not just limited to these instruments. We are actually combining the LC systems as well as different informatics of software as well. So we are going to launch the living laboratories in Thailand very soon, okay? Stay tuned with us, and I'm sure our partners, Bara Scientific, will give everybody a brief introduction very soon as well. Okay, so yeah, that's about my presentation. I hope you all enjoyed it. Anytime, do approach us in the booths of the Bara Scientific and Shimazu. Okay, thank you very much.
Please give a big round of applause. Thank you to excellent presentation to Nicole Zhang, LC-MS Product Manager from Shimazu Asia Pacific Singapore ทุกท่านได้รับทราบข้อมูลดีๆตลอดจนโซลูชันนะคะจาก Shimazu Asia Pacific กันไปแล้วค่ะสำหรับหัวข้อต่อไปนะคะจะเป็นอีกหนึ่งหัวข้อค่ะซึ่งได้รับการสนับสนุนนะคะหรือว่า co-organize โดย Bara Scientific Company Limited เช่นเดียวกันนะคะเราขอนำทุกท่านมาติดตามกันกับหัวข้อนี้ค่ะ EO and 2CE analysis in food and other metrics co-organized by Bara Scientific Company Limited และสำหรับหัวข้อนี้นั้นนะคะทุกท่านจะได้พบกับดร. Jackie Assistant Product Manager GC and GCMS จาก Shimazu Asia Pacific จากสิงคโปร์เช่นเดียวกันนะคะมาติดตามรับฟังไปพร้อมกันค่ะ Well, ladies and gentlemen, please join me in welcoming our speaker on the stage. We are honored to have Dr. Jackie Assistant Product Manager GC and GCMS Shimazu Asia Pacific Singapore.
Thank you, June. สวัสดีครับผมชื่อแจ็คกี้มาจากสิงคโปร์ทุกคนสวัสดีครับ Good morning, everyone. My name is Jackie, and today I'm very honored to be here to present to you about our solutions on EO and 2CE analysis. So this is a very recent hot topic that is found in especially the food safety aspect. Now you might be wondering, what is EO? Actually, I think many of us have heard of the ethylene oxide before, right? So what is ethylene oxide usually used for? Generally, we use ethylene oxide to do decontamination from E. coli, salmonella kind of microbial stuff. But this is usually done in the medical devices, not so much in food. However, recently, we have heard many scandals. There are many issues about ethylene oxide being found in food contents. So for example, we see the recall of instant noodle recently, and also on this ice cream, Haagen-Dazs. So this is a very big concern because ethylene oxide is carcinogenic when it enters the human body. So this is not supposed to be found in food, pharmaceutical kind of products. But just within a few months, recently, RASSF, this is an organization from Europe. They have found many contamination of ethylene oxide in different food contents. And just in April alone, there are 26 alerts. So this is a very major concern about ethylene oxide. Now, in this presentation, I'm going to introduce you first a little bit more about EO and 2CE, and then talk about how they are analyzed the standard way as well as the Shimazu way, which is superb. Now let's look at EO, ethylene oxide, and 2CE, which is 2-chloroethanol. These compounds, we know that it is dangerous to the human body. So actually, since 2000 plus, Europe has been creating a lot of regulation and guidelines about what is the amount of ethylene oxide that can be allowed in various food products. So on this list, we see the different kind of food product that is limited by EURL, which is listed in the year 2015. So it includes various spices, apicultural product, and also even food additive. And the latest information for food additive is updated just last month because we found ethylene oxide in food additive that is used to make ice cream. So that is called locust gum bean. And the amount that is allowed, that is inside the food additive, has been lowered from 0.2 ppb to now 0.1 ppb. So in fact, if you look at this whole list, the hardest to analyze would be the number 2, where you look at nuts, oil seeds, oil fruits to be only 5. Oh no, this number 3 and number 4 even lower at 20 ppb, sorry. 50 and 20 ppb, that is the lowest. Then, what is ethylene oxide and 2CE like? So on the left, you see ethylene oxide. This is the compound. It is a colorless gas. Usually it is gas because its boiling point is only 10 degrees. So at room temperature, it is a permanent gas. And that is why the analysis of ethylene oxide can be very difficult, because it is only gas. Nah? And then at the same time, 2-chloroethanol is the metabolite. So when ethylene oxide enters human body, for example, or during processing of food, if you have H+, Cl-, that means you just need water and salt, you can form 2CE, 2-chloroethanol. So usually, ethylene oxide can also be found in this form, which is also harmful for the human body. There are many ways to analyze the ethylene oxide and 2CE. In terms of the methods which are available in the industry, we have the first method, which requires Quecher's extraction, because we can consider it something like a pesticide, except it is a super volatile pesticide. Then there is also Q-oil method, or we can do conversion, because you remember, ethylene oxide is a permanent gas, but 2CE is easier to manage because it is higher boiling point. Then there are several methods, but there is also a new method that I will introduce in this presentation that is using headspace that requires almost no sample preparation. But the main challenge about ethylene oxide analysis is the fact that it is extremely volatile because it is a permanent gas at 10-degree boiling point. So whenever we have any sample preparation, we will tend to lose the EO. So it is very difficult to get repeatable results and also very sensitive result. If we want to convert EO to 2CE, then we will need to take time and then also use a lot of effort from human. Plus, there are also other kind of analysis you have seen in previous slide, where we use FID, ECD, or the GCMS single quad for analysis. But this is very limited in identification because it is very easy to get false positive using the MS, even mass spectrum single quad. This is the mass spectrum of ethylene oxide. You can see the compounds 44, 29. That is the main peak. And there are many things with 44, for example, CO2. So it is very easy to get you false positive and therefore are tough to get correct identification or even quantitation. And also, when we choose the column, because when we do some FID or ECD analysis, for example, the separation of the compound is extremely important. So if we use a column like 624, a polar column, then we can separate ethylene oxide very well from even compounds like acetaldehyde. But if it is not some other kind of column, then it will tend to overlap with each other. So quantitation may be difficult. But of course, we can solve it by choosing the right column. Nah? But when it comes to the identification for MS, GCMS single quad is not sufficient for ethylene oxide analysis. We need to use the GCMS-MS, which is triple quad, for this analysis. So let's talk about the standard way of performing EO analysis, which was already listed, recommended by the EURL. Now this is the full method description from EURL as a reference. On the left, we see the Q-oil method. On the right, it is the Quecher's method. If you compare them, they are really similar in terms of the sample preparation steps. Usually we have the extraction and then also the cleanup, centrifuge. So in this example, I am giving you oil seed as a reference. Sorry. What we need to do particularly is, because ethylene oxide is very volatile, so we need to use dry ice to put them together with the sample before we do the extraction, so that we minimize the loss of the ethylene oxide. But this step is also very difficult to handle, and therefore repeatability may be affected. So it has to be done carefully. And in this example that I'm going to show you, we did in our lab, we modified the experiment slightly for sesame seed. Sesame seed doesn't need so much dry ice, because it is mentioned that for tiny seed, we can just do homogenization and analyze. So we modify the method sample preparation, and then this is the result summary. So what you will see is that the linearity is perfect. It's from 5 to 100 ppb. So if you remember in the EURL, the reference method, the method to report for seeds are 50 ppb. So using the GCMS-MS, we can safely quantify down to even 5 ppb, 10 times lower than the required concentration range. And then we also have very good quality of result in terms of accuracy and also percentage RSD, or less than 10%. Then you heard about how this is also a very common issue in instant noodle. So when we are performing this in instant noodle, then we must use the dry ice because we don't want to lose our ethylene oxide. Now, so then at this example, we have also added in internal standard to improve the quality of quantitation result. In this analysis, you will see that the RSD is much better now because we are using internal standard method and with careful sample preparation. So for EO, we get accuracy of 101% and precision of 5%. And then for 2CE, accuracy is 110%, precision also less than 5%. So result is very good using the isotope label internal standard calibration method. And in this example, I am going to show you is when we are performing the analysis of ethylene oxide in chili powder. So the process is similar, but what we do is we add acid, you see H2SO4, and also NaCl to give the H plus and the Cl minus, so that we convert all the EO to 2CE before analysis. Why do we want to do that? Because if you have done analysis on the chili powder before, you know that it is a very difficult sample matrix. So we use conversion method, derivatization, to improve the result of the quantitation. And even though chili is an extremely tough sample matrix with high interference from the matrix, usually the coloring and other co-eluting compounds, we're still able to get very good linearity down to 10 ppb. Again, the reference in Europe says 50 ppb, or lowest is 20. So this is actually very good method as a standard way, with great accuracy and also repeatability. But then we know that all this standard analysis requires us to do a lot of sample preparation, many steps. So in Shimazu, we have developed a way better method that is based on headspace. This is possible because liquid injection itself is not exactly compatible with a very volatile compound like EO. As you would see, the original challenges, when we use GCMS-MS, we can overcome the other issue. But these 2 points cannot be overcome. We still have to do derivatization from EO to 2CE. We also need to perform careful sample preparation so that we do not lose any of the ethylene oxide in the sample. But if we use dynamic headspace, then we can overcome all these 2 steps challenges completely. And at the same time, there are additional advantages to using a headspace instrument. We know that sample preparation will be significantly easier. Very easy sample preparation. Later I will show you. And at the same time, method development is also much easier. We have developed it for you. As Nicole said, in Shimazu, we have method packages. So even for this, we have done everything, and then you can just copy the method and use it. At the same time, headspace is a technology that has very low carryover because we only let the volatile compound into the machine and then come out from the GC. So we don't let sample matrix enter the instrument, and therefore it will reduce all this sample matrix effect. Therefore, as a result, we will increase the reproducibility of result. Machine is not dirty, so it is most of the time running. You don't have to do so much maintenance. And very importantly, as we are working in the lab, chemical lab is always a little bit dangerous with all the chemical solvent being used. So using headspace, we almost don't need to use so much solvent. Therefore, it is safer when we work in the lab. Now, this is the step that we use in sample preparation for headspace extraction. You see how short it is. Only 4 steps. Much easier than when we are doing the quetches, coil, or also the conversion method. Because headspace is really very straightforward. And this is the result. We can see that the linearity as well as the chromatogram is really clear, easy for anybody to do quantitation. And here is the result summary. We get the same kind of linearity, still down to 10 ppb, but you can see that the result is so much more reliable in terms of the accuracy and also the repeatability. And the sample preparation is much easier. We don't even do any internal standard calibration. Using headspace, we can get an RSZ of less than 5%. So this is extremely useful when we are looking at having large sample amount and then when we are doing the work. So in Shimazu, we have developed 3 different methods for the analysis of ethylene oxide. All 3 are based on the dynamic headspace method. Method 1 is for the analysis of both the EO and 2CE. And then method 2 is only 2CE. Method 3 is only EO. So you can see that the summary of the result for all 3 methods are extremely good. Even though the EU MRL is only for 50 ppb, for example, for sesame seeds, but we can see that our result can all go down to a LOQ of less than 10 ppb. And then the RSD is also very good. So this is the advantage of using dynamic headspace. So if you are working in the lab, I think showing you result is one thing. Working on it is another thing. So I will be showing you a video where our chemist is doing the experiment. So on the left, you see this gentleman, our India colleague. He is going to showcase to you how he does the experiment using the headspace method. And on the left, this is our customer from India National Grade Research Center. She is going to show you her traditional method using the standard sample extraction, using the coil method. And then in this video, it will be totally voiced over by my India colleague, Mr. Sankat, and you can see how he and her are doing the sample preparation. And after that, we are also going to see a little bit of how the software is used in Shimazu system to process the data. Okay, so let's have a look at the actual sample prep.
Analysis of ATO and 2C is carried out with 2 techniques. Techniques are liquid and dynamic headspace. ATO and 2C reference standards are preserved in deep freezer at -40 degrees Celsius. Similar way, control and spiked sesame seed sample are also preserved in deep freezer at -40 degrees Celsius. Since this control sample is happened to be devoid of any ETO or 2C, part of it is used for spike recovery study. Other accessories and chemicals required for the analysis are shown here. Reference standards for ethylene oxide and 2-chloroethanol, control sample, 10 ppb pre-spike sample, headspace wire, syringe for headspace sample preparation, torsion tubes for liquid sample preparation, cleanup reagent for liquid sample preparation, liquid vial, headspace vial autocrimper, micropipettes for sample preparation. Do not reuse headspace vial septa. As the septa is already pierced, chances of loss of ethylene oxide during vial incubation. We recommend to use headspace vial autocrimper as it ensures proper and uniform vial crimping and minimizes manual crimping errors. In this demo, we are going to show you comparison of two methods, dynamic headspace and liquid injection. Here, comparison is shown with regards to sample preparation time, sample cleanup process, and final outcome of the both methods. For both techniques, chromatographic parameters are almost similar. Liquid sample preparation is shown by Dr. Reshma on the right screen. Liquid injection sample method involves weighing of the 2 gram of sample, add 4 ml acetonitrile, followed by the vortexing, centrifugation and cleanup process. Dynamic headspace sample preparation is shown by myself on the left screen. Dynamic headspace sample preparation involves weighing of 100 mg of sesame seed sample into the headspace vial, add 1 microliter of acetonitrile and crimp vial tightly. In dynamic headspace analysis, different calibration levels are prepared by spiking respective level of standard stock into the sesame seed samples. So on the left hand side, we have prepared 1 ppm, 3 ppm, 4 ppm, 5 ppm standard stock solutions which are used for the spiking in sesame seed. On the right hand side, Dr. Reshma is showing sample preparation for the liquid method. On the left hand side, I am showing the sample preparation for the dynamic headspace technique. So here I am adding 1 microliter acetonitrile by using syringe into 100 mg of sesame seed sample which is already taken into the headspace vial. Then crimp vial with auto crimper. This is the sample preparation for headspace. Similar way, different calibration levels are prepared by spiking 1 microliter of respective standard stock solution into previously weighed sesame seed samples. On the right hand side, Dr. Reshma is continuing with liquid sample preparation. She have already added 4 ml acetonitrile in sample and control sample. Next step in liquid sample preparation is vortexing. As per URL SRM analytical observation report, if the sample matrix is intact seeds, then we have to vortex the sample for 15 to 30 minutes. So here we have vortexing the sample for 15 minutes, followed by the centrifugation process. We keep the sample for centrifugation at 10 degrees Celsius at 5000 rpm for 10 minutes. Next step in the liquid injection is cleanup process. One cleanup cube is required for 1 ml sample. We combine cleanup reagent from 4 tubes into one Tarsen tube, which is used for matrix blank preparation. Here, Dr. Reshma is adding 4 ml of the supernant layer from control sample into the Tarsen tube, which already contained cleanup reagent. Similar way, sample vials are prepared. Vortex the sample for 1 minute, followed by the centrifugation at 10 degrees Celsius for 5000 rpm for 10 minutes. Clean supernant layer solution is obtained. Both samples are now ready for the analysis. As trap method showed substantial reduction in time required for sample preparation without compromise on final outcome. This method has cutting edge over liquid injection method. Now first we will show instrument parameters to be set for dynamic headspace analysis. From system configuration, set up the instrument parameters. Sampler is headspace sampler. Injection unit is headspace. APC1 is used for pressurization of the wire. These are the headspace method parameters. We are using dynamic headspace, so click on the trap. And these are the parameters for headspace, such as vial incubation temperature, trap cooling temperature, trap desorption temperature, vial incubation timing, etc. These are the chromatographic parameters. This is the injection unit, this is headspace. Column flow is of 2 ml. Split ratio is of 10. And mode is split mode. These are the column O1 parameters. Then APC1 is used to pressurize the vial of headspace. These are MS parameters, ion source temperature, interface temperature. Then these are the M by Z and collision energies of ethylene oxide and 2-chloroethanol respectively. Resolution is used Q1 unit and Q3 low. Download the method parameters and then create batch. Create batch, acetonitrile, control sample, that is on spike, then calibration levels 10 to 50, then sample solution in a duplicate. Then start the run. It will ask for ecology mode. So after run completion, we want to cool down the system. So I said no. And run will start. This is a real-time demonstration how vial goes inside. As the headspace runs are going on, we have created method and sequence for liquid injection. Here we have used offline editor software to create method and sequence. These are the auto sampler parameters. These are the liquid injector parameters. Here injector port temperature is 230 degrees Celsius, split ratio is pi, and remaining all other parameters are exactly like headspace parameters. Then we had prepared sequence for liquid sample analysis. Sequence is similar like headspace analysis. After completion of the headspace sequence, we had started liquid analysis sequence. After completion of the run, now let's see data integration of liquid process. Open Insight for GCMS. Then log in your credentials. On left hand side, there is an assistant bar. Go to the file, click on open. Change the file format to DAMLP. Open appropriate processing file. Here in one glance, you can see all the important data parameters. You can see R-square for both compounds and the data files used for plotting linearity and their levels. Now click on Import on Assistant bar to process all unknown data files. Firstly, we will import the diluent blank and unspike, that is control sample, to ensure they are devoid of analytes of interest. Then we will import sample runs prepared in duplicates. Now as you know, we have spiked the sample with 10 ppb. Under parameter accuracy, we cannot see any value. Now for obtain the recovery, we have to go to assistant bar, go into edit, click on edit tables and change the sample type from unknown to control. As soon as we do that, it will give you the recovery in terms of accuracy. Now to save the results, go to File and click Save As with different file name. Or if you want to overwrite, you can just click Save. Similarly, for HS data processing, open Insight. Go to File, open, select processing file in DAMLP, which already contains linearity data files as well as unknown sample data files. To obtain recovery or accuracy, click to Edit section on Assistant bar. Click on Edit Tables. Change sample type to control and click edit tables once again to see the accuracy results. To save these results and reproduce them as it is any time later, go to the file, click on save.
Hi, I'm back. So I hope you enjoyed watching the video. You saw this software. This was also the software that my colleague Nicole introduced earlier, the Lab Solution Insight. So what you see is in Shimazu, whether you are using GCMS or LCMS, actually it's the same software. So if you use one instrument and you switch to another, it's very user-friendly for you to learn. And in this case, we didn't see the color coding function, but it is available for our system as well, depending on how you use the software. But importantly, if you remember on the sample preparation, headspace method is less than 1 minute. But if you do the original standard method, it will take almost 1 hour, more than 30 minutes for sure, for you to do sample preparation. Even though we use less time, we get even better result. So that is the amazing power of the dynamic headspace method created by Shimazu. Now, so this is the summary of those methods that was mentioned. The first 3 methods will tend to take long time and also have some limitation, but our headspace method is extremely powerful. Minimal sample preparation. So this is the point where I want to introduce our product a little bit to you. We have this experiencing our UFMS, ultra-fast mass spectrometer from Shimazu, and you have seen this GCMS that was used throughout the presentation that has enhanced sensitivity, giving you superior performance, reliable operation, and also durable hardware. So what is our secret? Well, this is our GCMS, and when we break down the whole instrument, what we see is these all features that can make it extremely powerful. We have constant linear velocity mode, which can be extremely powerful when you are performing method transfer. Whether you are from GC to GCMS or GCMS to GC, or when you want to take other instrument and transfer the method to the Shimazu GCMS, it is extremely simple, easy, seamless transfer. And then it also comes with this brand new analytical experience. As a modern person living in a modern lab, we want to work nicely, like how Nicole said. Sometimes you want to work from anywhere, or even when you are working in the lab. All these features will help you to handle the instrument with more confidence. And then in terms of performance, we have the MS, which has extremely good noise reduction technology, which comes with all these features, giving you great performance, as well as the highest capacity vacuum pump. I think in Thailand, many people drive a car. So you know that in a car, engine is the most important point, the heart of the machine. So in GCMS, the heart is the pump, which allows us to even perform twin line analysis, combining 2 columns into the MS at the same time. So when you want to switch application, it's very easy. You just click software and you can change to different column. And also, let me go back. And also, it is compatible to the use of helium, hydrogen, or nitrogen carrier gas. So now that helium is a very expensive carrier gas, you want to switch to alternative gases, this allows you to convert very easily. And we also mentioned the headspace. So let's look at the features of our headspace. If you notice, our headspace look different from most of the headspace in the other places. If you don't believe, you can look around. There is always this thing called a long transfer line, mong chang. But our mong is very small, short, NX transfer line. It is only 30 cm, as you can see, connecting directly to the GC. And this allows us to have extremely good performance because there is no cold points. We can immediately transfer sample from the headspace to the GC. So there's no loss in performance. In terms of operation, it is also really efficient. We can do sample preparation that is way better than all the other kinds, as well as overlap analysis. When you want to do maintenance, it is also very simple, because in all Shimazu instruments, we have analytical intelligence, which makes your life easier. And finally, compliance is. We know that you may not be working on food alone. You may be working in compliance setting like pharma, or let's say in academia, you want to record everything that you are analyzing. Then we have all these compliance easy, friendly software and secure data network. And at the same time, particularly, we use trap mode to obtain extremely high sensitivity. This is useful because we know regulation these days keep changing. So today, we know that the regulation for EO in sesame seed, for example, is 50 ppb. And for some other compound, lowest is 20 ppb. But in a few more years, it may go down to 5 ppb, 2 ppb, for example. How are we going to keep up with the regulation change? So having an instrument like this can help you future-proof your lab. And if you are interested to find out more about ethylene oxide analysis, we have shown you multiple examples earlier on sesame seed, chili powder, instant noodle. So we are also developing more application. And then stay tuned with us to attain this application data book once it is available. And for those of you online, I know you might be interested to also learn more from Shimazu, as well as our guests over here physically. If you want to find out more about various solutions that Shimazu have, we have the digital classroom. You can just Google Shimazu digital classroom, and you can find all the different kinds of webinar recording that we have provided for various applications for free. So two of these topics that might be interesting to you is Mosh-Moa analysis on the left, and then on the right about automation. We have many more solutions, so if you want to find out more, go check out our website. And also, finally, in Thailand particularly, Shimazu is working very closely with Para Scientific to bring you the bio, circular, and green economy. We are here to support you, and we hope that if you have any questions, you can feel free to contact us. Stay connected with us. If you want, you can add me on LinkedIn over here. And if you have any questions, you can find us at the booth over there. So I practice my Thai sentence for this to close my presentation. ถ้ามีคำถามอะไรเจอผมที่บูธปารานนท์ขอบคุณมากครับ
ขอบคุณมากค่ะ and thank you very much to Jackie.
Thank you.
So you have to practice Thai and have conversation with our guests and everyone here. Once again, thank you very much for your useful presentation, the sharing with us today. Please keep contact with the team from Shimazu. Please kindly visit at that booth for more information further. สำหรับท่านใดนะคะที่ได้รับฟังโซลูชันรวมถึงข้อมูลที่น่าสนใจทางด้านเทคโนโลยีและนวัตกรรมจากที่ทางคุณแจ็คกี้ได้นำเสนอไปนะคะทุกท่านสามารถสอบถามรายละเอียดเพิ่มเติมกันได้กับที่บูธของชิมัสึนั่นเองซึ่งวันนี้มีทีมงานหลายท่านนะคะก็พร้อมที่จะต้อนรับทุกท่านอยู่นะคะเพื่อให้ข้อมูลอื่นๆเพิ่มเติมกับทุกท่านค่ะสำหรับในช่วงเวลานี้นะคะเราจะพักกันสักครู่โดยเราจะกลับมาพบกันอีกครั้งในช่วงเวลา 13 นาฬิกาเป็นต้นไปอย่าพลาดค่ะที่จะมาร่วมรุ้นและร่วมเชียร์นะคะสำหรับผู้ที่จะมาเข้าสู่การแข่งขันกับ Pitch and Partner 2022 นั่นเองกลับมาพบกันอีกครั้งในช่วงเวลา 13 นาฬิกานะคะ So we'd like to thank you very much for your kind participation. We shall now take a break and the programs here at Live and Bio Square will be resumed at 1 p.m. So don't miss to stand a chance to cheer them up for 8 finalists who will compete the stage with the Pitch and Partner 2022. We shall now to take a break and we'll be right back. Thank you very much.